The other type of structure that is very important to understand for Ethernet is the frame itself. Now, this is somewhat of the container for the data that is actually being sent from an application. You'll notice that regardless of whether or not we look at a standard Ethernet frame, which would be considered ARPA Ethernet or DIX Ethernet, or if I'm looking at Ethernet IEEE 802.3, you can see that our data portion is always between 46 and 1500 bytes. We always have the same amount of information. Now, the maximum size of the overall frame will be 1518 bytes. That includes 1500 plus 6 and 6, that is 12. You notice that we have the 2, which is 14, plus we have 4, which is the frame check sequence. That's 1518 bytes. A lot of times we see this listed as 1514 bytes. That would be everything besides the actual frame check sequence. The preamble, or the startup frame, never counts against our count, because this is a set of 8 zeros which will indicate the start of a frame. Therefore, a receiving station knows where the very first bit of the frame itself actually exists, and that's the purpose of the preamble, or the startup frame component. Of course, the frame check sequence, or sequence redundancy check, is computed at the end as the 4-byte field, which identifies everything from the destination address field all the way to the very last bit of data. This identifies that the packet itself has been received with a high level of integrity. You will notice that our destination address is always the very first component of an Ethernet frame, regardless of the frame's type, whether it's Ethernet standard or 802.3. So this is the destination MAC address. This is the source MAC address, where it's coming from. We then will have an option between a type and a length field. If it's Ethernet, which uses 802.2 LLC, which is everything today that's common, we'll actually have a type field, which will identify the type format for the packet itself. Following this is the layer 3 through 7 data and the frame check sequence. If it's industry standard, 802.3 from IEEE, which is what Novell NetWare used for Ethernet, we will have a length field instead of a type, followed by all 802.2 LLC information, which is going to be bound inside of the data portion, and then following that is the frame check sequence. So you see that the frames are slightly different. When we deal with TCP/IP communications, we're focused on the frame on the top with an 8-byte preamble, a 6-byte destination and source address field, a 2-byte type field, an 846 to 1500 byte data field, and finally followed by a 4-byte frame check sequence. That's what we would see when looking at Ethernet frames if we are ever dealing with the packet sniffer.